Okay, guys, I'm going to try to clarify things with ethanoic acid and acetic acid. They're the same thing, okay? So think of ethanoic acid as the superhero name and acetic acid or acetic acid as like just its ordinary name, kind of like Batman and Bruce Wayne, all right? So they love using this on the Regents, and that's where you see it in all the questions because the CH3COOH is an organic acid. So it's in the organic acid family. So if we scroll down here to organics and how they get named and stuff, went too far. Here's your organics. These lines are really bothering me. Here's your, whoops, what did I do? Here's your organics. I'm erasing these lines. So all these, the COOH is the same kind of polyatomic ion as C2, what's it, H3, O2. All right, so here we have it here. So all they do is, since these are negative, they put a hydrogen plus here, and they put a hydrogen plus here. Now here's where it gets tricky, and this is why they love using this. They know that you know that an OH is Arrhenius, will give away a base. So they know that you're going to see this OH and always think it's a base because you're not thinking that the H is on the outside of it. But it's a different OH. So this OH is a polyatomic ion, right? It's right here. So it's connected covalently together, but in a base right here, it's bonded ionically to, like, say, sodium. However, if we go to an organic compound or organic acid like CH3, sorry, COOH. Oh, this is just horrible. Let me scroll down. I like sound effects. Let's go here. This is covalently bonded right here. This is a covalent bond right there. That's my poor attempt at a at an arrow, right? So NaOH is technically this. All right. So this OH is covalently bonded to the carbon. This OH is ionically bonded. That's what makes it a base. This is organic, so it's covalent. So it's really hard to dissolve when they get larger, but none of these are going to be able to dissolve in water. Organic acids have their own little place when it comes to organics. So if we can go back to table K, and let me get the eraser and get all this stuff out of here. They're always going to want to use ethanoic acid on a test, and you saw it was like 3 questions, is because they want you to think that since it ends in an OH, that it is a base. But it's not, because the reality is this is the polyatomic ion. It's just written differently like this. The other thing is that you have to realize is according to that video that you watched, the only name that real chemists actually use for acetic acid is ethanoic acid. That's the only name that we kind of actually really use. Not we. I'm not an official chemist. I just play one in a classroom. So I hope that was helpful. Again, the tricks that they're trying to get, they want you to see this, not this. COOH. And here they're just kind of throwing this at you, just showing you an alternative form that really isn't used at all. When we get into organics too, it gets really tricky because OH also is an alcohol, which is just another ball of wax. I probably shouldn't have brought it up. Okay, so I hope that's helpful, and please let me know if it was or not.